Okay, so in your book on page 59 has nice, pretty pictures for these things. So if we're looking at your epithelial tissue, and squamous are nice flat cells, but I like to think of them as like fried eggs, because there's the nucleus. And these are what you find on the outside. So right up here you have squamous cells on the outside of your skin, and you want these to fit really tightly together, and that's why they're flat and they kind of all fit nice and tight, because we need this skin to be waterproof as well as any type of pathogen proof, so we don't want any breaks in it. So they do fit nice and tight together. You also have what is called cuboidal cells. And just like they sound, they are cube-shaped. Columnar look like cylinders or upstanding rectangles. And their nuclei are always way down at the bottom. You'll see these in something that secretes, so lots of glands you'll see. Now your epithelial also has what are called layers. So you have a simple, which would be one layer, and that's it. One small layer. Your capillaries are actually simple squamous or squamous. You can pronounce it either way. That would be a capillary. So on top you'd have all the way around a tube shaped of these cells. But they're only one layer, and that's because in between these capillaries, or in between these cells, we have little openings at the ends. They're not completely sealed off shut. So this allows for when blood is rushing through here, we can push things out. Not big things like red blood cells. These red blood cells can't go out. But you can have glucose go out. You can have oxygen go out through that. And so as this capillary is coming by a tissue, it can drop off oxygen and food, as well as picking up waste products and CO2. So we need them just to be one layer. So that's a simple squamous. And you can have a simple columnar, you can have a simple cuboidal. Simple just means one layer and that's it. Stratified. So here's another this is another squamous cells. Stratified are stacked. We'll have many layers. So your skin is stratified squamous. We have many, many layers. Because what if you just had one layer? What would happen?
It would probably like tear.
Yeah, it would tear and break very easily. You can slide across the asphalt and get a little abrasions, but it's not completely open and you seeing muscle. Say again.
That's like when old people, their skin, like, you know how it tears?
Yes, it's very thin. Yes. Because as they get older, they don't do mitosis as quickly and as efficiently as we do. So our skin is very thick, and they lose some fat underneath their skin. And we're going to talk about that in the next lecture on integumentary system. We'll talk about what happens as we get older. Okay, so that's pretty simple. Simple is one layer, and stratified is two layers. Not difficult. Okay, so which one is true of epithelial? So this would be the skin on the outside. Do you think it has a blood supply at all? It doesn't. Because you can scratch, you can get, I'm scratching there and you can see the scratches. But it's not bleeding. So we do not have a blood supply. Granular epithelial, so this is still epithelial tissue, but think of granular, I'm thinking of cells. Glandular meaning glands, so we give rise to glands. We have two different types of glands you need to be aware of, and again, this will come up in the next lecture, Chapter 5, Integumentary System. We'll cover this stuff again. So know it now, because it'll help you out for next lecture. Exocrine, so it exits through a duct, or endocrine, it enters the blood. So think exocrine exiting through a duct, or endocrine going straight into the blood system. Other types of tissue, we have connective tissue. Connective tissue, we have a whole lot of it. There's more connective tissue than there is any other type of tissue. And it's because it kind of classifies a lot of things. So you have cartilage in here, we have ligaments, we have adipose, which is your fat, reticular, so this is going to create some organs, in particular the spleen. Areolar, which is going to be underneath your skin, so you have your epithelial tissue, and then underneath that you have connective tissue. Because if we didn't, then we could easily just slide, our skin would slide off, and you can move it around. So like pushing a tube sock down and pulling it back out, that would be your skin. We don't want that. So it connects it. Connective tissue connects things. So with your ligaments and your dense fibrous connective tissue, it's connecting bone to bone. Cartilage connecting vertebrae here. Reticular, we'll talk about. Adipose, and not only is fat tissue, you think of fat, I don't need it, but it does help to protect. So it will hold things up in place, and it will protect organs. Bones. Bone is a type of connective tissue, very strong and dense. Areolar, connecting muscle to skin so it doesn't move around. And then we have blood. Blood is a connective tissue to where it's connecting the entire body, is communicating through blood. Big thing about your connective tissue is what's called the extracellular matrix. So this is what makes up connective tissue, the very basis of it. What is it made of? So some protein and some fluids. And these fibers, they can be cartilaginous, rectangular, or fibrous. And so here's some of our fibrous with loose and dense. We have cartilage, bone, and blood. Let's look at them. So areolar tissue, right underneath our skin again, we have areolar tissue connecting us to our muscle so our skin doesn't slide around. Adipose, when you think adipose, think fat, because that's what it is. And reticular, we are creating some organs with it. Dense connective tissue. When you're thinking tendons and ligaments, we want it to be strong because it's connecting bones, or it's connecting bones to muscle. So it needs to be very dense and strong. Few blood vessels. So when you tear ligaments or tendons, then they really don't heal themselves very well. It'll take... Sometimes we can watch and see if there's a small tear and it may heal itself, but the blood supply is poor, so it doesn't do a great job, and a lot of times you have to end up having surgery. It can also, your dense connective can form a fascia. Fascia is like when you have your chicken and you tear off the skin, and you see that shiny that is over the muscle, like the chicken leg, it's real shiny and kind of slippery. That is fascia. It holds like groups of muscles together. So it's strong. It's a dense connective tissue. It is strong, and it'll hold everything together. What type of tissue lies underneath almost all the epithelial and connects tissues and organs together? So really think underneath the skin. Which one was that? It is areolar. Areolar connects our skin to our muscle. Okay, so still looking at our dense. Let's move on to our cartilage. So we moved out of loose connective tissue and dense connective tissue, looking at cartilage. Chondrocytes, so it's made up of a special type of cell. When we get into other, like bone, we'll look at osteocytes. But cartilage has its own cell, chondrocytes. So you think cartilage, think C for chondrocytes. And this is very, very rubbery and flexible. So think about the end of your nose. cartilage.
Or like
So,
right.
yeah, or your ears, cartilage. Problem with it is it doesn't have any blood vessels. So if you do have a break or tear in it, then you're not going to repair. And so a lot of the times they will just go in there and remove that cartilage. They won't try to...
Does it hurt?
The surgery, no, not necessarily, because they can do it laparoscopically
Like
anymore. Yeah, they can do a little hole, go in there, fix it, repair it, and be done.
No,
But not having that cartilage, say in joints that are really weight-bearing, knees and things, yeah, over time it's going to hurt because you're going to have bone rubbing on bone, and that's not good. So, looking at cartilage, we have different types of cartilage even. So if you're looking at your book on page 62, I love the illustrations because they simply put them in a nice little box and show you exactly what's what. So your hyaline cartilage, think of your joints. That's hyaline cartilage. It's on page 62. So hyaline cartilage, you need it because of these joints do not need to be rubbing bone to bone, because then we'll end up with some osteoarthritis. Lots of pain and stiffness. Cherish.
What is it when they have the extra cartilage, like your ears over?
They can fold their ears over and what?
Like my cousin, she's able to take her ear and completely fold it over, and she has the left beat. Isn't there a special name for that cartilage?
I have no idea. No, I mean the cartilage that's there is elastic cartilage, but there's a condition then if something's weird with it.
and cartilage like shrinks down, doesn't it? It like
Shrinks down?
well, because my friend in her ears, she doesn't have cartilage in her ears, so they're like big. Like why is it? Like, it's like all like straight like that.
Yeah.
It's not like bent over, so like this cartilage like.
No. But there can be, I don't know why hers would be, she has cartilage, because if her ears are erect and out, she has cartilage. But why they are just, yeah, it would be just, yeah, flop, kind of like a puppy dog, yeah. So yeah, she has cartilage, but why it looks a little different, I don't know. But yeah, she definitely has it. Okay, so you do need to know that hyaline cartilage you'll find between joints, so that they'll slide over each other smoothly. Your elastic cartilage, that's where you're going to find lots of ears, nose, even in the esophagus, we'll have some or epiglottis, we'll have some high elastic cartilage. Fibrocartilage, you can see some in between the vertebrae, and then we have some in the knee joint. But just know that those three things, we have hyaline, elastic, and fibrocartilage. You don't have to know exactly what falls underneath those, but do know that those are the three classes of types of cartilage we have. Okay, bone. Bone, we have osseous tissue, and we have osteocytes that are making up its matrix or making up bone. This is a nice place for extra calcium that we can store, and we have red bone marrow inside there, which is red bone marrow. Again, these are all connective tissues. Blood, lastly, it is a connective tissue still, and we don't have any fibers, but so the matrix or the basis of blood is just plasma. So that's the water part of blood. Again, we'll cover all those tissues later on in their own lectures. So all of that, blood, bone, cartilage, ligaments, loose and dense connective, all those are connective tissues.
Miss Lynn?
Yes?
When, you know how when we gave blood, like, you get